Have you ever made a glass of lemonade and thought, it's too sweet? That sweetness depends on how much sugar you've added compared to the water. In chemistry, we call that the concentration of the solution. From hospital drips to industrial chemicals, the concentration of solutions plays a vital role in daily life and science. In this lesson, we'll learn what concentration means and the different ways to express it step by step. In simple terms, concentration refers to the amount of solute present in a given quantity of solution or solvent. Solutions can be dilute, having a small amount of solute, concentrated, containing a large amount of solute, but these are just qualitative terms. In chemistry, we need quantitative ways to express concentration so that measurements are precise, repeatable, and universal. Let's explore the standard methods to express concentration.
The mass percentage is the mass of solute in 100 grams of solution. It's widely used in chemical industries. The formula is mass percent equals mass of solute divided by total mass of solution multiplied by 100. Example, if 10 grams of glucose is dissolved in 90 grams of water, the solution has total mass is 10 plus 90 equals 100 grams, so mass percent of glucose equals to 10 divided by 100 multiplied to 100, and that is 10%.
This method is commonly used when both solute and solvent are liquids. Volume percentage is also called volume by volume concentration of solute. It is defined as the amount of solute in ml present in 100 milliliters of the solution. For example, a 35% volume by volume solution of ethylene glycol in water is used as antifreeze in car engines. That means 35 milliliters of ethylene glycol is present in 100 milliliters of solution. This unit is especially common in biology and medicine. Mass by volume percent equals to mass of solute in grams divided by volume of solution in milliliters, multiply into 100. Let's say a saline solution is labeled as 0.9% mass by volume. This means 0.9 grams of salt is dissolved in 100 milliliters of solution. When dealing with extremely small quantities, especially in environmental science, we use parts per million or ppm. Parts per million means the number of parts of solute present per 1 million parts of the solution. Parts per million is used to measure the concentration of quantities present in trace amounts. ppm equals parts of solute divided by total parts of solution multiplied by 10 raised to the power 6. The mole fraction is the ratio of the number of moles of a component to the total moles in the solution. The mole fraction of A equals the number of moles of A divided by the sum of moles of A and B. Important points to remember. The sum of all mole fractions in a solution is always 1. It's a unitless number. It is temperature independent. Molarity is the number of moles of solute dissolved per liter of solution. Molarity, also moles of solute, volume of solution in liters. Let's take a quick example. If 5 grams of sodium hydroxidase dissolved in 450 milliliters of solution, find molarity. First, calculate moles of sodium hydroxide. Molar mass is 40 grams per mole. Moles equals to 5 divided by 40, and that will be 0.1125 moles. Volume is 450 divided by 1000 equals to 0.45 liters. Molarity will be 0.125 divided by 0.45 equals to 0.278 molar. Let's understand molality, a way to express concentration. Molality is defined as the number of moles of solute per kilogram of solvent. The formula is molality equals moles of solute divided by mass of solvent in kilograms. Let's look at an example. Suppose you dissolve 2.5 grams of acetic acid in 75 grams of benzene. First, calculate the moles of acetic acid. Its molar mass is 60 grams per mole. So moles of solute is 2.5 divided by 60, which gives us 0.0417 moles. Now convert the solvent mass. 75 grams is 0.075 kilograms. Finally, apply the formula. Molality is 0.0417 divided by 0.075 equals to 0.556 molal. This is how we calculate molality. Simple, consistent, and independent of temperature. Let's quickly recap what we've learned. Concentration tells us how much solute is present in a solution, and there are several ways to express it. Mass percent, volume, percent, mass by volume percent, parts per million, mole fraction, molarity, molality. Each of these units serves a different purpose, so choose the one that fits your situation best. In the next video, we'll dive into solubility and explore the factors that affect it. Stay tuned.